Hello everybody, in today's video we're going to analyze one of the way how to solve a quadratic equation. So today we have Vieta's formula. In Russia it's called Vieta's theorem, but this information is for those who are really interested in cultural and linguistic differences between the countries, but never mind. So we can use this way, Vieta's formula, for such equations: x squared plus p times x plus q equals 0, where p and q are some coefficients. And just keep in mind that to use Vieta's formula, we must have a coefficient that stands next x squared equal 1. So for instance, if we have here 3, this method is not applicable anymore. We either divide both of the parts by 3, or we choose another way how to solve this equation. But let's assume that we have this coefficient equal 1. So this Vieta's formula tells us that if we sum the roots of this equation, let's assume that there are 2 roots, and if we sum them, then we should receive the coefficient that stands next x, however with the opposite sign. That means if we have plus p here, then we should have minus p here, and vice versa. However, if we multiply these roots, we should receive the constant term, that means q. And everything is in the system. So 2 equations should be true. So let's analyze an example. So we have x squared plus 3 times x minus 4 equals 0. Is Vieta's formula applicable here? Yes, since the coefficient that stands next is x squared equals 1. So, according to Vieta's formula, the sum of the roots of this equation should equal the coefficient that stands next x, however with the opposite sign, so minus 3 here. And if we multiply these roots, we should receive minus 4, this constant term. So it's up to you how to solve this system. You can either solve this by substitution of x2 using x1 and vice versa, or you can just guess these roots. So if we guess the roots, then we have the roots minus 4 and 1. And that is correct, because if we sum them, we receive minus 3 indeed. And if we multiply them, we receive minus 4. So minus 4 and 1 are the roots of this quadratic equation. However, if we have a situation when the coefficient that stands next, x squared, does not equal 1, this method is no longer applicable unless you divide both divides by this coefficient so that you get x squared only. So x squared here should be alone, with no partner. Okay? So either you divide both parts, and here you have issues with coefficients, since they are no longer integers. Well, at least this coefficient that stands near x, it would be 1.5. It would be a bit difficult to solve this equation using Vieta's formula. However, you can use the discriminant formula to solve this quadratic equation, or just creating groups. Well, that's it for today. If you like this video, press the like button and don't forget to subscribe this channel. See you next time, guys.